Can you hear me, Nevada?
Yes, I can hear you. Can you hear me? Mariam, are you able to hear me?
Hello, everybody. Can everybody hear me okay? Or maybe, Nev, if you can just wave or let me know you can hear me.
Yes, we can hear you.
Our Rebel Grad Slam preliminary rounds were last week, and those were not live. Those were all pre-recorded. So this is our first time going live. So all the semifinals today, all 3 sessions are live, but this is our first one. So we want to make sure the tech is perfect. If y'all just want to give us a few minutes. Jason, I see you're on. Can you shake your head if you can hear me? Awesome. Thank you so much. Appreciate it. Mariam, I see in the chat you said you can't hear anything. Did you want to turn on your mic or maybe you can't hear me say this?
Actually, I connected with my cell phone because I don't know why I cannot hear anything from my computer. I was wondering if the quality of my cell phone is cool here.
Do you want us to turn on your camera there and we can just make sure it's working? Yeah, it looks good.
Okay, so let me put my cell phone here. Is it cool? I cannot see anything,
Looks good.
but that's fine. There's no way out, but, well, technical difficulties.
2020.
Okay.
Thanks, Mariam.
Sure.
All right, it looks like we are ready to start. So good morning and welcome. My name is Valerie Burke and I'm the Assistant Dean of Graduate Student Services, and I'm so excited to welcome you to our 7th annual Rebel Grad Slam 3-minute thesis competition. We're excited to say that not even COVID could stop the Rebel Grad Slam. So thank you all for joining us today. I'd like to begin with going over a few items. So slammers and judges, please make sure to keep your microphone on mute and video off when other competitors are presenting. Only turn on your microphone and video when you are presenting. Please be sure to stay for the entire session, even after we are done presenting. If you have any questions, please type them in the chat in between presenters. Please do not use the chat during anyone's presentations as it can be distracting. You may sit or stand while presenting. You may also wear a mask while presenting. Judges will not penalize you for doing so. You only have 2 minutes and 59 seconds and 1 chance to compete. Once you begin speaking, we will start the timer and you will not be able to restart unless something beyond your control occurs. If you are presenting and your dog barks in the background, just keep presenting. Please don't stop unless I stop you. Don't worry though, if you lose Wi-Fi or are disconnected, please just join back in. We will wait a minute for you and then go on to the next presenter. If that happens, you can redo your presentation at the end. Also, please remember that you may not read your presentation or use any notes or the screen or what's in front of you. Any questions from the presenters or judges before we begin today's event?
Hi, Valerie. I have a question. When do we ask?
All right.
When do the judges ask?
Seeing any at the moment?
Hi, Valerie. Can you
Super.
hear me?
Yes. Your mic's off, but I can't hear you.
I just
I can
unmuted
hear her.
myself.
I can hear her.
Can you hear me?
Yeah.
I was just asking, when are we supposed to ask our questions? Okay.
You can ask any
It says
questions
guys
you
can
have
hear
about
her,
the
but I
event now.
can't. That's
No,
weird.
when do we ask the questions to the presenters at the end, right?
You're not going to be asking them questions. You're just going to be scoring their presentation at the end of their round.
Oh, okay. Okay. Thanks.
Okay, I can hear it now. That was weird. Everything's okay, Nev?
Yeah, I was just asking if the judges are supposed to ask questions.
Oh.
And I think we are not supposed to ask questions,
No,
right?
no questions. Correct. Thank you, though. Great question.
Thanks. Yeah.
Okay. Looks like everything is going well. Okay. So the 3-minute thesis or 3MT competition model was developed at the University of Queensland in Australia in 2008. It spread to other universities in Australia and New Zealand in 2009 and 2010. By 2011, the 3MT competition phenomenon had spread around the globe, and now more than 600 universities from more than 65 countries hold these competitions. In 2014, UNLV held our first 3MT, the Rebel Grad Slam. And this year, it's our 7th annual Research Rumble. The 3MT is a fantastic opportunity for students to learn how to convey who they are, what they study, why they study it, how they study it, and what they found or expect to find, and why it matters to an audience of folks who are mostly outside their field. It is an opportunity to build public speaking and communication skills and to polish one's elevator speech describing what they study as graduate students. It's worth noting that our slammers come from all over campus and from a wide range of disciplines. Some are first-year students, some are in their final year. Some slammers are master's students, and others are advanced doctoral candidates. So today we have a group of UNLV graduate students who have been randomly, nope, that's not right. Now we have our semifinalists who have won their preliminary rounds, and they are here to compete to move on to the next round for the finals. We each will present their research in 3 minutes or less using one slide and no props. We will introduce each student and then start the timer. If a student goes over 3 minutes, they will be eliminated from the competition. Slammers are encouraged to pace themselves and use their 3 minutes without going over. It's not easy, but it's what the 3MT is all about. The judges will be assessing the competitors based on metrics, which total 24 possible points in 4 major areas: comprehension, content, engagement, and communication. Each judge will independently score each competitor. Judges will not penalize competitors for wearing masks to present or for unanticipated disruptions that are beyond the slammer's control. We are adapting a bit to respond to the unique challenges of this first ever virtual competition. At the end of the presentations, we will tally the judges' combined scores for each grad slammer and announce the winners. The top three in this session will advance to the next round. In total, we had almost 100 students compete in the preliminary rounds. We have 36 students competing in the semifinals, and about 9 students will advance to the finals at 4 p.m. on Wednesday, November 18th. The top 3 grad slammers in the final round will be awarded scholarship in honor of their accomplishment. So without further ado, let me introduce the judges and then we'll get on with the Research Rumble. We have a set of very distinguished judges in today's session. Judges, if you want, you can turn on your cameras and give a wave as I say your name. And if you don't want to, that's okay too. I just wanted to give you the option. First, we have Professor William Bauer from the College of Liberal Arts, Department of History. Next, we have Associate Professor Sarah Jordan from the School of Medicine, Couple and Family Therapy Department. Assistant Professor Subright Bunzel from College of Engineering, Mechanical Engineering. Professor and Vice Provost for Academic Affairs, Javier Rodriguez from the College of Sciences, School of Life Sciences. And from our Dean's Leadership Council, we have Susie Stern. Also from our Dean's Leadership Council, Heather Palmer, who's a double alumni. And Jason Thomas is an alumnus, a CPA, and also a community judge. Thank you all for being here today. Oh, and I do see Associate Professor Nemat Hassan, School of Dental Medicine, Biomedical Science. Thank you. So welcome and thank you for serving on our distinguished panel of judges today. So we are ready to begin the competition and cue up our first presenter. At this time, we'll want everybody to make sure their mics are off and their cameras are off, so there are no distractions. And as a reminder, not to use the text box unless it's in between presenters. I think I see everyone is good to go. So let me introduce Katherine Lubeck. She is from the her advisor is Dr. David Hatchett. She's pursuing a Doctor of Philosophy in Radiochemistry, and the title of Katherine's presentation is Uranium, or How I Learned to Stop Worrying and Dissolve the Molecule.
In the year 2020, I can understand why you might be hesitant to see the word uranium pop up just about anywhere. But let me share a few things I've learned from my research that might help you put that worry to bed. The first is that if we want any sort of reliable, carbon-free energy future, that future has to involve nuclear. As you can see from my first graph, nuclear energy operates at full efficiency, twice as much as any carbon-based form of energy, and 2 to 3 times as much as renewable energies. This means that in places where renewable energies may not be reliable, viable, or financially acceptable, and carbon energy is something that we wish to move away from, nuclear can fill in the gap and give us an option for a new energy source that can operate reliably way more often than anything else. The second is that our nuclear energy pathways are actually very safe. These are things that have been tested over decades, that we know very well exactly what's happening at every stage, from mining our uranium, which can be done domestically, interestingly enough, all the way through to creating nuclear fuel pellets and using those to generate electricity. A little secret here, uranium mining causes less waste than your average coal plant does. But I hear you, less waste doesn't mean no waste, and waste is something we would all like to get rid of at this point. My research has demonstrated that using nothing more than the air we breathe, a very simple ozone generator, and uranium in multiple different chemical formats, I can take this spent uranium waste and convert it into a liquid form that, requiring nothing more than the energy used to charge your cell phone or to power all of these online meetings we've been doing all year, can turn that into harvestable, recyclable uranium. But what does one do with recycled uranium? Well, in addition to our clean energy sources, we can also use this uranium for cutting-edge scientific discoveries of new elements. We can recycle all of the nuclear fuel that has already been used and is sitting in stockpiles around our country. And excitingly enough, there are applications for treaty verification, meaning that we can use these techniques to not only give us a better source of energy for our country, but throughout the globe, we can create a safe environment for testing and using nuclear fuel. Thank you.
Thank you. So in between each presenter, we're just going to give like a minute and a half so judges can judge. And I think we're going to have a little music in the background. This is our first try. It's first time trying this, so I bet it goes perfect though. Okay, I think we're ready for presenter number 2. There's Dante. Okay, so our next presenter is Dante Miller, Doctor of Philosophy and Sociology, advisors Dr. David Dickens, and Dante's presentation is From Slavery to Platinum Plans as Told by Donald Trump and Black Republicans.
I'm Dante Miller, second-year PhD student from the state of Iowa, and I study Black Republicans. Now, you're probably asking yourself 2 questions right now. 1, do Black people live in Iowa? Nope. And do Black people vote for Republicans? Yes. As a matter of fact, it's historically accurate. From the post-Civil War era through Reconstruction to the New Deal era, Black people overwhelmingly voted for the Republican Party because they were the party of civil rights. But then when it became politically costly for Republicans, well, they dropped Black folks like a hotcake and didn't think twice about it. This left Black people politically homeless for almost 2 decades until the 1960s, when Democrats were taking losses up and down the ballot and needed to build a winning coalition. To do this, they took up civil rights, and well, that's been Black folks' political home ever since. Fast forwarding to 2016, and 8% of Black people still voted for Republicans, and in 2020, that number rose to 12%. Journalists began scratching their heads like, how could Black people vote for Republicans? They're racist, and Black people don't like racist. Well, that's where my research comes in. I'm analyzing the question of what is the relationship between perceived racial progress and political party affiliation among Black people in the United States. To analyze this, I'll be looking at a Pew data set from 2019 that focuses on thoughts on diversity and inclusion, racial progress, and Donald Trump's handling of race relations, dividing 1,344 Black people into 2 groups, Democrats and Republicans, and analyzing their thoughts on racial progress. So far, what I'm finding is that Black Democrats are overly pessimistic about racial progress in the United States, while Black Republicans are overly optimistic about racial progress in the United States. Highlighting this information changes the political landscape for racial progress because both parties are actively vying for Black votes now. An example of this happens when Donald Trump releases his Platinum Plan for Black America, which focuses on economic prosperity, while Joe Biden and Kamala Harris released their plan for safer policing in Black communities. Both parties have never actually vied for Black votes at one time until this year, the first time in over 50 years, as a matter of fact. My research simply lays out the best way for racial progress to happen inside of the United States, because if both parties see that there is a difference in how Black people think about racial progress, then that means more policies will be tailored towards them specifically. Black folks single-handedly have the most power with their vote right now, and maybe we'll finally see racial progress in the United States sooner rather than later. Thank you.
Thank you. And I'll cue the music for 90 seconds. Okay. We're ready for presenter number 3. Okay, our next presenter is Kendra Mclan, pursuing a Doctor of Philosophy in Neuroscience, advisor Dr. Justin Hines, and Kendra will be presenting on astrocytes' effect on cortical circuitry and motor behavior.
Ever since I was a little girl, I have always been captivated by the broad spectrums of movement the human body could produce and the extraordinary people who produce them, even when the odds were stacked against them. Whether it was world-renowned ballerina Lauren Anderson defying gravity with a single leap, or novelist and poet Maya Angelou using her hands and lips to articulate a new world into existence wherever movement was, a masterpiece seemed to follow, even in the face of adversity. You see, movement is what gives rise to all forms of communication. It's how we write, how we speak, how we engage with others and the world around us. It all comes back down to the contractions of muscles. The ability to adapt and coordinate movement is the most important and complex thing our brains do. We know that when this process is interrupted, it leads to a variety of neurological problems like neurodegeneration. A common characteristic of many neurodegenerative disorders like multiple sclerosis or ALS is a deficit in motor capabilities. And when we look at the research on these disorders, there is a heavy emphasis on the impact of neuronal dysfunction. However, glial cells, like astrocytes, that actually make up a large majority of our brain, tend to fall to the background. The goal of my research is to examine how astrocytes impact motor movement, even if the odds have been stacked against them. So to test this, we utilize a multi-level approach where we examine the brain activity and movement of mice. Now, these mice were genetically altered for the astrocytes in the motor cortex of the brain to be activated by a drug. After we introduced our mutated mice to the drug, we then looked at quantifying and recording their brain activity. You can see that in A. And what we have for our mutated mice illustrated in red was this increase of brain waves right before they started moving, suggesting that how they planned their movement was different. We then took it a step further, and we looked at how this brain activity outputted in motor behavior. And we placed our mutated mice through a variety of motor tasks that you can see illustrated on the right. And what we saw was a decrease in the level of efficiency and coordination in mice in which the only thing different are the astrocytes, suggesting that astrocytes play a critical role in how we modulate and coordinate our motor behaviors. I'm excited to say that after exploring a cell type that some researchers have written off as the most unlikely of places, just like Lauren Anderson and Maya Angelou, there too is a masterpiece. Thank you.
Thank you. And now we will turn on the music for 90 seconds for our judges. Okay, we are ready for our next slammer. Our next presenter is Mario Mata. Advisor is Dr. Jeremy Chow. And Mario is pursuing a Doctor of Philosophy in Mechanical Engineering. The topic of the presentation is the importance of foams.
Hi, have you ever noticed how the foam on top of a cappuccino reduces the sloshing and becomes harder to run the coffee over the rim? Or have you also observed how the frothy foam of a fresh beer slowly collapses? These are two clear examples where you might encounter foam, and that dynamic behavior really intrigues me. Foam, in appearance, is a very simple material, maybe because at some point in our life we are all familiar with it, whether it is dish soaps or laundry detergents. But you see, actually foam is a very complex and dynamic material. But what is foam? Foam is a collection of tiny bubbles created by active agents. what is an active agent? Might be a surfactant or a detergent. Let's have a look to some more example where you might encounter foams in the fermentation process. For the pharmaceutical industries, when they are creating drugs, vaccines, and antibiotics, there is a buildup in their machines when they are creating these products. If you don't control and monitor this process, that might potentially ruin the product or even the machine itself. So you see, foams are everywhere. In my research, I focus and I want to study the effects of foam in liquids with certain type of surfactants. For instance, in the slide, I show you a solution of water with the surfactant called Twin 20. This Twin 20 surfactant is widely used in domestic, scientific, and pharmacological applications. I observed how in the period of 3 hours, this foam decay. I could control the environmental conditions. But why we are doing this? This is very interesting because not only the understanding of how we study these will benefit us in the lab, but also in the industrial applications, but something that might be also beneficial for the boiling, in the boiling field. You are also familiar what is boiling. For example, when you boil water, yes, and you create vast amount of bubbles, and that's something called bubble coalescence occur. So what we want to address in our lab is foamability with bubble coalescence. By doing so, we can create really good technologies that might enhance our current and future technologies in the energy sector. But let's have a look if you actually understand what is foam. Just go to your kitchen. When you go to wash your clothes, you see foams are everywhere, and all of us, we should care about what is foam. Next time when you go for a drink, and if there is some foam, think about it. And yes, thank you for your attention.
Thank you. Let's cue the music. All right, we are ready for our next presenter. Our next presenter is Christian Isom, advisor Dr. Janet Tufek and Dr. Mohammed Trabia. Christian is pursuing a Doctor of Philosophy in Interdisciplinary Health. And the presentation today is on assessing center of pressure with the progression of diabetes and diabetic peripheral neuropathy.
According to the CDC, more than 34 million people in the United States are currently diagnosed with diabetes. Diabetes is the 7th leading cause of death in the United States, and it is the #1 cause of adult blindness, kidney failure, and lower limb amputations. More than 80% of these lower limb amputations begin with a foot ulcer. A foot ulcer is an open sore or wound that develops on the plantar surface of the foot and can occur due to a loss of feeling in one's feet due to nerve damage and poor blood circulation. This condition of diabetes-caused nerve damage is termed diabetic peripheral neuropathy. About half of all people with diabetes will eventually develop neuropathy. In addition to the risk of ulcerations and eventually amputations, researchers have found that those who suffer from neuropathy are seen to have a greater risk of falls due to impaired balance. In fact, a person with diabetes is 17 times more likely to suffer a fall than a person without diabetes. The question now becomes, is there some sort of measure that indicates a person's balance impairment at the feet? The answer to that question is yes. Researchers currently use foot excursion measures to assess balance by examining deviations in the center of pressure, or COP. COP represents the force applied by the foot with the supporting ground surface, and it is determined by assessing the anterior posterior, or forward and backward, and medial lateral, or side to side sway, as you can see in the lower left corner of the screen. Thus, researchers suggest that decreases in forward and backward sway and increases in side-to-side sway are indeed indicative of impaired balance. However, there is no current literature that determines if COP measures are seen to linearly change with this worsening progression of diabetes. Therefore, the purpose of the proposed study will be to explore the relationship between these deviations in COP using pressure measuring insoles as seen on the screen here for those who are pre-diabetic, diabetic without neuropathy, and diabetic with neuropathy. We hypothesize that decreases in forward and backward sway and increases in side-to-side sway will be proportional to the progression of diabetes and neuropathy. We hope that the implications of our study will provide a better understanding of the progression of balance impairment for those who suffer from diabetes. Thank you.
Thank you. Okay, and we are ready for our next presenter. Next, we have Mariam, Mahadin, Rod, advisor Dr. Christine Clark, and Mariam is pursuing a Doctor of Education in Curriculum and Instruction. Mariam's presentation today is Embracing Diversity, Creating an Inclusive Campus Climate for All Minorities, a case study of Muslim students.
Excuse me, isn't it too hot here for you to be covering your head? Just a quick question. Are you allowed to study, work, or drive as a woman in your country? You have to share your husband with another woman in your faith, don't you? These kind of questions might look shocking to you, but a typical Muslim woman may encounter them frequently, even here in the United States, as one of the most diverse countries in the world. These feelings perpetuate marginalization and seclusion of minorities, but this is definitely not what we want here. This is totally in contrast with affirming diversity and inclusion in a multicultural society. While the United States is embracing diversity and inclusion and proud of celebrating that, a deeper dive into the various layers of the society reveals the overt and covert discrimination and racism against minorities such as Muslims. Every year, thousands of Muslim students from all around the globe come to the United States pursuing their education, but insufficient support for minorities has created a broad spectrum of challenges in their campus lives. Numerous research have investigated the campus life challenges and experiences and the key contributing factors to this. In most cases, though, the key contributing factor and the triggering factor was lack of knowledge and education regarding the real Islam and Islamic culture. For further investigation, I conducted a case study through semi-structured interviews with 10 Muslim female students regarding the race-based and religious-based challenges in their campus lives. The interview results facilitate developing practical suggestions for campus officials to listen to minorities' voices and mitigate their challenges on campus. The practical suggestions seek to reduce marginalization and seclusion of Muslim students by raising awareness and optimize their academic development by de-escalating racial tensions. This research has significant contributions to embracing diversity and inclusion, enhancing the quality of campus life for minorities, and fostering a multicultural campus climate pleasant to study, work, and live for all students. Thank you.
Thank you.
Sure.
Let's cue the music while the judges work. Okay. We are ready for our next slammer. Next, we have Amit pursuing a Doctor of Philosophy in Civil and Environmental Engineering. Amit's advisor is Dr. Erica Marty, and Amit will be presenting on chloroform in water, occurrence and removal.
Hello everyone,
Well, chloroform is an organic compound that has one carbon, three chlorine, and one hydrogen atom. Normally, in nature, they are produced by marine algae. However, the one that ends up in our water supply system is from anthropogenic sources like industries and laboratories, where they are used and produced as solvent for different chemical procedures. Adding insult to injury, they are also produced in water treatment plants. So why does it matter? It matters because it has several health impacts on the human beings. US Environmental Protection Agency has categorized chloroform as probable carcinogens, and they have regulated them. In US, the maximum concentration of chloroform that can be present in water is 100 parts per billion. To put things into perspective, in Las Vegas last year, the average concentration of chloroform in our water, drinking water, was 63 parts per billion. So we are not that far from the threshold. Considering these perils, it is imperative for us to remove chloroform from our water supply system. There are various methods that have been developed. Dehalogenation is one of the emerging techniques out of them. Dehalogenation simply means removal of chlorine atoms and replacing them with hydrogen in presence of a catalyst. During my master's thesis, I conducted a similar experiment with palladium as a catalyst and studied the degradation of chloroform at normal lab conditions. After the experiment, I found out that chloroform degraded directly into methane with small traces of intermediate compounds. Of course, the intermediate compounds are also harmful to human health, but they are in so small quantity that they can be regulated and moved easily. In the experiment, I found out that almost half of the chloroform degraded within first 10 minutes, and in 3 hours, the chloroform was completely gone. So in conclusion, we can say that degradation method that includes reductive dehalogenation with palladium as a catalyst can be used as a very effective method in removal of chloroform from our drinking water supplies. So, and the methane that are generated during the process can also be commercialized and used in energy production. Also, although the efficiency of the process was high in lab conditions, the effectiveness of this process in normal field condition is still to be studied. Thank you very much.
Thank you.
Thank you.
Okay, we are ready for our next presenter. Cody, I just want to make sure your camera and mic are working. Oh, there we go. Okay. Our next presenter is Cody Chris, pursuing a Master of Science in Biological Sciences. Advisor is Dr. Helen Wing, and Cody will be presenting on virulence gene activation in Shigella flexneri, a major dysentery pathogen.
Thank you. Diarrheal diseases are among the leading causes of death globally, accounting for 1.6 million deaths in 2017 alone. Among children, there are 1.7 billion cases each year, and in children under the age of 5, it is the second leading cause of death, accounting for 1 in 9 of all childhood deaths. In the developing world, a major cause of diarrheal disease is the pathogen Shigella flexneri, which you can see imaged here in the top center of the slide. Shigella is a bacterium that is transmitted person to person via fecal and oral routes, whereby it enters the gastrointestinal tract and destroys the lining of the gut, leading to a severe and painful form of dysentery. At this time, there are no approved vaccines against Shigella. A crucial step in a Shigella infection is the activation of genes that enable Shigella to cause disease. Those disease-causing genes are called virulence genes. My research focuses on how those virulence genes are activated once Shigella gets into the human body. As you can see in the image in the bottom left, when Shigella is outside of the human body, the DNA is wrapped up by a protein called HNS to keep those virulence genes turned off. But once Shigella gets into the human body, a different protein called VIR-B somehow displaces HNS from the DNA, thereby leading to the DNA unwrapping and those virulence genes being turned on. However, what's not well understood is how VIR-B actually displaces HNS from the DNA. Shown in the top right is that my hypothesis is that VIR-B binds to the DNA and then recruits more copies of itself that then spread along the DNA, leading to that HNS being kicked off and those virulence genes being activated. I intend to test this hypothesis using well-established molecular biology and biochemistry techniques. The insight generated from my research will allow us to better characterize how Shigella controls its ability to cause disease. Additionally, the mechanisms of virulence gene activation in Shigella are likely to resemble those in other bacteria as well. Therefore, the outcomes of my research extend beyond Shigella and may lead to a better understanding of how other bacterial pathogens cause disease as well. Ultimately, this provides us an opportunity to identify novel drug targets, which may lead to the development of new antibiotics or identification of antibiotics and antibacterials and therapies to help treat and fight against diarrheal diseases and more. Thank you.
Thank you. Okay, we are ready for our next presenter. Our next presenter is Robert Cochran, pursuing a Doctor of Philosophy in Kinesiology. Our advisor is Dr. Gabrielle Wolf, and Robert will be presenting on improv to improve Parkinson's disease.
The two most important words in improvisation are yes and. Yes is the acceptance of the situation, and is what you'll do to add to that. So keep that in mind as we go forward. Yes and. My dad was diagnosed with depression or with Parkinson's in 2001. He was told that he'd be in a wheelchair sometime between 6 months and 30 years from that date. It's a pretty crappy diagnosis. In 2004, we went on the Boys of Summer documentary tour. Now, what that meant was 2 months, 20,000 miles on the road together to see a game at each of the 30 Major League ballparks together and discover what Parkinson's was by talking to doctors and people with Parkinson's. What we found was that there's approximately 1 million people with Parkinson's in the US. That's the fastest growing neurological disorder in the world. And that although it doesn't kill you, it can really take away your quality of life. Things like anxiety, depression, and especially isolation are very common and quite dangerous. So in 2004, there was a rally cry at the time, the cure within 10 years. And that was really great because that would say, yes, we don't have to do anything and we'll have that thing happen within 10 years. Well, in 2014, 10 years later, yes, there was no cure, and that meant we'd have to focus on quality of life because that's all we had. I was very concerned because I could see my dad feeling stuck and scared and frankly beginning to isolate himself. So we began to look at that moment outwardly, and I found a paper by Northwestern University, which in 2016, they said it was the first ever of its kind, said, here's a look at what improv can do for people with Parkinson's. They found it lowered depression, anxiety, even stigma. It brought people together. They were collaborating. So again, out of isolation, this was good. There needs to be more research. Well, yes, I've got a background in improvisation, and sure, I'll go back for my PhD at 50. Who cares, right? We got to do something to figure this out. So I did. Now, what is improvisation? Well, it's unplanned collaborative response. That middle word collaborative is really important because you're not on your own when you're improvising. We improvise together, and it's an exercise. Picture this. Participant 1 says, I'm going to try this delicious hot dog. Participant 2 said, yes, and it could use some ketchup. The ketchup is the unplanned collaborative response for the hot dog. Now, there's a researcher named Charles Lim with UC San Francisco, and he's looked at improvisers inside of an fMRI, and he's found that the medial prefrontal cortex is activated while they're improvising. That means that they're open to new types of collaboration and insight. They're flowing, they're in the zone. So this is good for getting people out of isolation. Yes, improv can help people with Parkinson's, and we're going to keep working on finding out how to do that. Thank you.
Thank you. Okay, and we are ready for our next presenter. Our next presenter is Matthew Cooper. Advisor is Assistant Professor Yan Zhao. And Matthew is pursuing a Doctor of Philosophy in Physics. He will be presenting on ultra-cold molecular ions can teach us new physics beyond the standard model.
One of the fundamental mysteries in our universe is the apparent imbalance between matter and antimatter. During the Big Bang, equal amounts of matter and antimatter were created. This could be possible if matter and antimatter decay at different rates. We suspect this might be the case because 13.8 billion years later, our world is composed of mostly matter. These different decay rates could be possible if some laws of physics operate differently depending on whether time is moving forward or backwards. For instance, the spin of an electron will go in the opposite direction if time is moving backwards, and the resultant magnetic moment will flip. However, if the electron has an electric dipole moment, an uneven distribution of charge over its mass, this property would stay the same whether time is moving forward or backwards. If we can determine if the electron has an EDM and what its magnitude is, we can prove or disprove certain theories beyond the standard model of particle physics that attempt to explain the matter-antimatter imbalance. The EDM is sensitive to and will align along the local electric field. So the bigger the electric field, the better your measurement of the electron's EDM. In my PhD research, I plan to use molecular ions to measure the electron's EDM. The advantage of molecular ions is that the effective electric field within them is orders of magnitude larger than any electric field you can create in the laboratory conventionally. I plan to contain these molecular ions like thorium fluoride using a rotating electric field that prevents it from leaving my trap. Then I plan to slow it down so that I can study it by entangling it with atomic ions like a terbium that can be laser cooled. It's very important that I ensure that my measurement of the electron's EDM is statistically significant. I can improve the quality of my data by fabricating an array of molecular ion traps on a microchip to increase my measurement rate. The beauty of this project is that whether or not I'm able to successfully measure the electron's EDM, I'll have created a platform on which I can perform research in other topics like particle physics, nuclear physics, or cosmology by changing the species of molecular ions that's studied in my trap. Thank you.
Thank you. Okay, we are ready for our next presenter. Our next presenter is Andrew Ortiz. Advisor is Dr. Jefferson Kenny. And Andrew is pursuing a Doctor of Philosophy in Interdisciplinary Health Sciences, Department of Brain Health. The presentation today will be on the link between Alzheimer's disease and type 2 diabetes.
Alzheimer's disease is arguably one of the most devastating illnesses that afflicts families. Essentially, what makes us individuals, our memories, starts to slowly vanish. Now, there are several risk factors that increase the likelihood of developing Alzheimer's disease. For example, type 2 diabetes is one of the largest. People with type 2 diabetes are up to 4 times more likely to develop Alzheimer's disease, and 80% of people who do have Alzheimer's disease are type 2 diabetic or have some degree of glucose or sugar intolerance. Some researchers even call this disease type 3 diabetes. However, the exact mechanism or exactly how type 2 diabetes is conferring risk to Alzheimer's remains unknown, and that is what my research attempts to uncover. Okay, so the brain is essentially composed of the connection between billions and billions of brain cells called neurons. And in Alzheimer's, what happens is that these connections and brain cells start to die over time. As a result, the brain deteriorates and gets smaller in size, as you can see in figure 1. So what is causing the cell death? So figure 2 is an image depicting what's occurring in an Alzheimer's brain at the microscopic level. Now, there are 3 pathologies or 3 things that are seen in late-stage Alzheimer's disease that are causing the cell death. The first one are these huge brown A-beta plaques in figure 2 that are composed of a small little protein called beta amyloid in figure 3. Now, this protein is very sticky, and what happens is that they start to stick to each other outside of the cell and form these plaques that interrupt cell communication and cause cell death. The second pathology are tau tangles in blue in figure 2. Now, this is composed of a protein called tau in figure 3. Tau is a protein that holds the cell's communication structures together. Think of it as cement to a building. And in Alzheimer's, this protein detaches from the cell and starts to clump inside of the cell, causing the cell to collapse and die. Now, A-beta plaques, tau tangles, and even type 2 diabetes on its own can initiate an immune response in the brain called neuroinflammation. Essentially, you have immune cells in the brain that go into a chronic state of attack mode. And during this attack mode, they release toxic chemicals that over a long period of time start to damage all the cells in the brain. Now, several studies have already confirmed that type 2 diabetes can exacerbate Alzheimer's pathology. So it increases the plaques, it increases tangles, it initiates the immune response, and this collectively leads to progressive brain cell death, as you can see in figure 5. Hyperglycemia, or high sugar levels in the blood, is a main characteristic of diabetes, and we believe that this is a mechanism by which, or is a way that type 2 diabetes is conferring risk to Alzheimer's. That being said, all my research revolves around utilizing drugs that allow me to alter sugar levels in the blood in rodents and examine the effects it has in the brain in relation to Alzheimer's. I hope that this research can help ameliorate or develop therapeutics for this devastating disease. Thank you very much.
Thank you. Okay, we are ready for our next presenter. Tamera Win's advisor is Dr. Dale Devitt, and she is pursuing a Doctor of Philosophy in Biological Sciences. Her presentation today is microenvironment and rainwater harvesting cause greater growth in native plant life and a novel build for solar energy facilities.
I'm so excited to tell you about my research today. I study a big project with native Nevadan plants with Dale Devitt, and I'm just going to tell you about a small portion of it. First, I want to tell you how the desert is a very fragile and diverse ecosystem. You can see this first picture is an 800-year-old trail from an Anasazi, and it is still visible. Native plants have not recolonized. This is an extreme example. There are some trails that are 50 to 100 years old that are just beginning to colonize. So the problem is there's a particular increase in building solar facilities, and this is displacing a lot of native plants that may not recover. But I study a particularly interesting build in Pahrump, Nevada, where they left the plants inside next to panels, and this is a place where plants can live. If you look at this first picture, you can see where the panels are sloped, where rainwater falls off into the edge, what we call the drip line, and native plants are growing along this edge. It also has increased soil moisture, which we measure with a theta probe down to 1 meter at 6 different depths. We also study a native perennial shrub that grows on the drip line of the panels, underneath, and in the middle. This is showing that outside the facility, they're brown and stressed. Inside the facility, they're green and happy. So why is this? We think this is due to shade and increased winter temperatures underneath the panels. We measure photosynthesis and transpiration with a very fancy machine called the Lycor 6400. It's about $50,000 and one of the most published pieces of equipment in science. And so what we're seeing is that these plants are photosynthesizing inside the facility versus outside. We're also looking at whether this affects the long-term storage of sugars in the roots and stems, which would affect the long-term health of the plant. If these sugars are being used up, then they will be exhausted and possibly cause a downward spiral of the plants in the long term. So in the short term, we're seeing that these plants are happier and less stressed inside the facility. And in the long term, we're unsure of whether these plants may be down a downward trajectory. However, we hope that this facility that keeps the plants inside maintains a healthy habitat and also maintains food and habitat for the desert tortoise and other animals. Thank you.
Thank you. Now I'm going to give the judges the 90 seconds to score our last presenter. And then after that, we're going to have a little intermission with additional music while we tally up the scores and see who our top 3 finalists are. So if y'all can just give us some time, I'll be right back. That concludes the time for the judges to finish their scoring the last presenter. Just in case you couldn't hear me, that concludes the 90 seconds for the judges to score our last presenter. Now we'll just have a brief intermission so that we can tally all the scores and pick our final three. So we will put the music back on and be right back. Okay, everybody, we are back and ready to announce our semifinals first session winners. Again, thank you all so much for joining us for our semifinal rounds. A special thank you to the Grad College Leadership and Professional Development Team, especially Nevanon Savetic, who made this 3MT event possible. And thank you to our tech hosts for this session, Marlena Gatlin and Jessica Soria. We are ready to announce live our top three. And while only the top three winners of this round will progress to the semifinals, you are all winners of a Rebel Grad Slam t-shirt. And let me tell you, they are super cool. We will be in touch with everyone after finals to arrange pickup dates. Are you ready? Here are the winners of this semifinals session. In third place, we have a tie. In third place, we have Kendra Mclan and Andrew Ortiz. And with a tie, both will move on to the final round. In second place, we have Cody Chris. And in first place, we have Christian Eisen. Congratulations to all of this round's winners. We look forward to seeing you present on Wednesday. All the winners will receive an email from us with further directions, so please watch for that today. And everyone, thank you again for your participation, and we hope that everyone will join us for the final round on Wednesday, November 18th at 4 o'clock. Thank you.